Okay, for continuing our work from yesterday with ellipses, we ultimately have the same set of rules that we worked with yesterday. The only difference is that the center is not going to be at 0, 0. So if we have a center at HK, okay, finding the information about the focal axis, the foci, vertices, okay, semi-minor, semi-major axes, and also the Pythagorean relation, none of that changes. Okay, the only issue is that everything gets translated to where the vertex is, or excuse me, where the center is. Okay, so again, H and K is going to be the center of our ellipse instead of 0, 0. Okay, all the work we're going to do is going to be almost exactly the same. So just a visual. Once again, if we have the major axis being horizontal, okay, we have HK in the middle. If we know the C value, that allows us to find the positions of the foci. So it's going to be C to the right, C to the left. Okay, and then the vertex on the right and left are always going to be A to the right and left of the center. Okay, and they don't have it labeled on here, but these 2 points here that are going to make up the other part, okay, those are always going to be B from the center, B up and B down. Okay, opposite when we have one that's major axis vertical. Okay, again the furthest ones are the A's, if you will. Okay, the foci are again C away from the center, and these 2 points on the side are going to be B away from the center. Okay. All right, so let's take a look at the problem here. They asked us to find the standard form of the equation for the ellipse whose minor axis has endpoints 1, 4, and 5, 4, and whose major axis has a length of 8. So I personally would draw a picture, okay, to help myself. I know I got 1, 4, okay, and then 1, 2, 3, 5, 5, 4. Okay, those are the endpoints of the minor axis. Okay, so that means that the minor axis is horizontal, which makes the major axis vertical. Okay, it says the major axis has length 8. Okay, so if it has length 8, keep in mind, again, this isn't part of the ellipse here, but if I were to connect those, okay, those 2 axes need to cross in the middle of each other. So if I were to go 4 down from the middle, which would be right there, okay, that would be the endpoint of my major axis, so 3, 0. And then also 1, 2, 3, 4 up would be the other point, which would be 3, 8. And that would give me a major axis with length 8. And at that point I could draw a picture of the ellipse. And again, my scale is not that good here because I'm not a good artist, but ultimately we're going to go 4 up and 4 down from that line that connects the 2 minor axes endpoints. Okay? Now, if we're going to write the standard form equation for the ellipse, okay, we need to recognize that it's going to be of the form x minus h, y minus k equals 1. And then underneath, I'd put the a squared here and the b squared here because of the fact that the a squared is always bigger. Okay? And let's go ahead and start filling in some blanks. So if this is my picture, then right there in the middle is going to be our center point, which is going to be 3, 4. So I'd have x minus 3 squared, y minus 4 squared. So again, just like a puzzle, I'm filling in some blanks here as I go. And let's talk about A first. The A value, remember, is the distance from the center to the endpoints of the major axis. So the A value here would be 4. So we'd have 4 squared, which of course is 16. And then on the other one, in the minor axis, okay, the minor axis, the distance from the center to the endpoint of the minor axis is 2. So we'd have 2 squared. And ultimately our final answer then beneath that would be 4. So if this were the picture of our ellipse, okay, with those different parts that were given, okay, then this would have to be our equation. Okay, center at 3, 4. Minor axis has a length of 4. Okay, 2 plus 2. Major axis has a length of 8. Okay, square root of this is 4. So 4 up and 4 down, etc. Okay. Okay, questions on that process? All right. Let's take a look at, oops, there we are. This time we're given an equation. Instead of writing the equation is given to us, and we have to identify center, vertices, and foci. So center is just HK, so center would be -1, 1. Okay. And once again, I like to draw myself a picture. Okay. So if my center is at negative 1, 1, there I am here at the center. I can see that the bigger number is under y. Okay, so that means my a value here would be 3. My b value then would be 2, square roots of each of those. So if I'm going to draw my major axis, I'm going to go 3 up and 3 down. Okay. So 3 up and 3 down would give me the vertices, which are the endpoints of the major axis. So my vertices are going to be at negative 1, 4. 3 up from the center point. And negative 1, negative 2, which would be 3 down from the center point. Okay. And we can go ahead and find the minor axis also. Okay. And we could draw a picture. We don't need to in this case because they didn't ask us to. But the other thing that we had to find is what are the values of the foci, what are the points, locations of the foci, and that's where we need to use a squared equals b squared plus c squared. Okay, so we know that 9 here and 4 here would give us 5 if we subtract, so that means the square root of 5 would be our c value. Okay, and again, they're going to be on the same axis as the vertices are on, so the two foci are going to be at negative 1, and then we're going to go radical 5 up from the center. Okay, so remember we're at 1 for the center, so it would be 1 plus radical 5, and make sure you leave it like that. Should no good reason to put a decimal answer for that. Same thing here. If we go 1 minus radical 5, that would be the location of the other focus. Okay, and if we did get a decimal to plot the points, obviously they would be within these two, between the center and the vertex in both directions, both positive and negative. Okay. And again, when we report them, just leave them just like that unless it tells you otherwise. Okay. Questions so far? Okay. All right. There's one other thing I want to look at here. That's this application of ellipses. Okay. A lot of times the orbits around the sun are elliptical. Okay. Instead of it going in a circle around the sun, planets and other objects usually go in terms of an ellipse. Okay. And the sun is generally one of the foci. Okay. And so if this is the orbit for the object, whatever it may be, whether it's a planet or some other object, okay, there are a couple of vocabulary words in here I want you to know, because if this comes up in Jeopardy when you're watching it, you might want to be able to get those right. So when we're in an orbit, the closest point to the sun, okay, at the end of the major axis, we call that the perihelion. Okay? And then the furthest away distance that the object is from the sun is this one, which we call the aphelion. Okay? All right. And then there's one other thing that we're going to calculate regarding ellipses, and that's their eccentricity. So the eccentricity is calculated by just doing c divided by a. Okay? And remember, c is found by doing a squared minus b squared, and then taking the square root. So it's the same c from our Pythagorean relation, which is a squared equals b squared plus c squared. So if we know a and b, then we can find c. And of course, if we know c and a, then we can find the eccentricity. Okay? All right. Any questions so far? Okay, so for your work today, you're going to finish up the A2 assignment, working with some ellipses that have centers that are not at the origin, and also with a couple of eccentricity problems. Okay. All right.